Hi, in this video I'm going to explain another example for linear approximation. In this case, my goal is to approximate the cubic root of 65, letting be f of x the cubic root of x. My closest known value would be 64. This cubic root of 64, which is equal to 4. I got here on the right in blue, the formula we'll be using so far in every case, and I draw here is on the left the graph of actually it's not a graph of the cubic root of x, and I'm not even referencing here the value of 64 and 64 plus the delta x, because my goal is letting it as letters, as variables, because actually my thing is, in principle, this same principle could be applied to any situation that you're trying to do a linear approximation. Now let's see. Let's try to find this dy. Dy would be equal to f prime. Sorry, it's very ugly. F would be the f prime of 64. So I'm going to use a different color here. I'm going to use here this yellow one. This f prime of 64 times the differential of x. I'm going to use for differential of x green. Differential of x, there it is. Now let's get the f prime of 64. So we start with the f of x being the cubic root of x. So it's f prime of x would be equal to, first I'm going to use it, remember to transform this into numeric value, would be x raised to 1/3. So in other words, it would be equal to 1/3, its derivative, times x raised to the 2/3, negative 2/3. So f prime of x would be equal to 1/3 raised to 2/3. I mean, raised to the 2/3. Now let's find f prime of 64. This would be equal to 1/3 times 64 raised to the 2/3. Now I'm going to use a bit of manipulation here with exponents in order to make it easier to solve this out. So this would be the same as saying it's 64 raised to the 1/3. It's a 1/3 or squared. The 64 raised to the 1/3 squared. If you multiply the exponents, you will get the same you had here previously. The 64 raised to the 1/3 is just the same as saying this cubic root of 64, which we already know is equal to 4. So f prime of 64 would be equal to 1/3 times 4. This would be 4 squared. So this 4 squared would be 16. Would be 3 times 16. That would be equal to 1/48. So this is our f prime of 64. I'm going to better frame it. There it is, f prime of 64. So let's keep on with this. Dy it's equal to f prime of 64. We know it's equal to 1/48. Now it will be times the dx. Dx, I'm going to use here brackets, parentheses, I mean. Dx would be equal to 65 minus 64, which it's obviously 1. So the dy would be equal to 1/48. Now remember, we are not looking for the dy in this case. We are looking for the in this case it would be, I'm going to use a different color. I'm going to use orange here. Would be we are looking actually for this the cubic root of 65, which in other words would be f of 65, and we know this is approximately, I mean, dy represents only this height, but we are not looking only this height, we are looking for this one. So we must add, in order to get this one, we must add this height. This height is actually the f of a. So we must add in here, the f of a in this case would be f of 64. So let's add here f, this is a very ugly 6, f of 64 plus a differential. That's our goal is to find this whole height, all this. So if we add up this one plus this one, we will get an approximation of f of 65. So let's see, it would be f of 65, which is approximately f of 64. We already know it's equal to 4, so it would be 4 plus the dy that we know it's equal to 1 over 648, 1 over 48, and with that we are done. This is actually the linear approximation that we are looking for the cubic root of 63. Now you can look for and verify on your calculator this quite nice approximation.